So we've finished with order of operations, moving on to algebraic expressions and equations. We're actually starting to get into some algebra now. Look at what I want you to be able to do. I can define a variable or variables in the context of a problem. You might not know what that means yet. I'm going to tell you later on in the video. I can write an algebraic expression or equation from words. So you're going to be starting to write expressions and equations using algebra. Okay. First of all, what is a variable? A variable is an unknown or changing quantity. So it can either be unknown, so find the missing number, or it can be something that's changing. So within the same problem, it has different values. A letter is typically used to represent a variable. It doesn't have to be, but more often than not, like 99.9% of the time in this class, I'm going to use a letter. Okay? These two things here are big. This can tell you a lot when you see them in your instructions. If you understand the difference between the two, it helps a lot. An algebraic expression is a mathematical phrase that includes at least one variable and does not contain an equal sign. All right? What makes it algebraic is the fact that it has a variable. Okay, order of operations, there was no variable in those. Those were just simply expressions. They were not algebraic expressions. What makes them algebraic is the fact that they have a variable. Okay? An algebraic equation is a mathematical sentence that includes at least one variable and does contain an equal sign. Okay? Now, the equal sign is like the word is, which has other forms. Example, are, was is past tense of is. So those words, not always, but a lot of times they mean equals. Okay? Now, why is that important? That word can change a phrase into a sentence, and I've made note of those up here, phrase and sentence. Let me give you an example. A number increased by 4. That's not a full thought. That's a phrase. A number increased by 4. That is a phrase. Algebraically, the way we write that is a number, we're going to call it x, increased by, or add 4. Notice no equal sign. It's an expression. A number increased by 4 is 7. That is a full thought. It is a sentence. Algebraically, we can write it, a number increased by 4, which is, we already have that, is equals 7. And now we can actually solve that problem. Okay? So the big thing from the front, the first half there, make sure you know the difference between an expression and an equation. Defining a variable. Big idea here at the beginning of the year, when you start using variables a lot. We don't use it as much later on, but it is a good habit to get into. When we define a variable, or variables, because you can have more than one, we are stating what our letter represents, or stands for, in a specific situation. Without doing this, our variable has no meaning. It's just a letter. So, you'll see me say this. Define a variable and write an algebraic expression, or maybe it's an equation, for the following phrase. Notice I said expression, though. What symbol should definitely not show up? You should not have an equal sign. Okay? Well, define a variable. Well, what we don't know in these 4 words is Mark's weight. This is the unknown number. That is the unknown quantity. So that's what we can use for our variable. So we're going to replace Mark's weight with a variable. Call it M, and this part right here is the defining part. We're just saying what M stands for. M stands for Mark's weight. Okay, so now when we write an expression, we don't have to write that whole thing. We can just replace Mark's weight with the letter M. Minus 12. And there's my expression. Okay, so some practice here. Define a variable and write an algebraic expression for each phrase. These are all expressions here. The quotient of triple a number and 7. What do we not know? Well, we don't know what the number is. That's our unknown. So I'm going to define that using the letter N. You don't have to use N. You can use a different letter. N is just representing a number, or an unknown number if you want to write that. Okay, so now we want to write an expression. What does quotient mean? That means division, right? So the division, the answer to a division problem of what two things? Triple a number. How do I write triple a number? Triple means 3 times what number? We don't know. N. So triple a number and 7. So quotient is the answer to division, so I'm dividing triple a number and 7. So doing 3n divided by 7. Okay? I want to give you a chance to try all that here. I will help you with the defining of the variable, but I want you to try to write the expression. 2/3 of the amount increased by 5. What we don't know is the amount. That's my variable. A is representing the amount. Okay. Moving on to number 3. 1 less than the number of children. What we don't know is, I'm going to do this wrong at the beginning. A lot of people will say C equals children. Keep in mind, a variable is an unknown or changing quantity. Children is a noun. It's not a number yet. Amount is. An amount is a number. A number is an unknown number. Children is not a number. Children is a thing, right? So this is a minor issue, but it is an issue. I'm not using that as my definition. What I'm using is C is number of children. That is a number. It's an unknown number, but it is a number. So number of children we're replacing with C. Now another thing I'm going to do wrong is I'm going to say 1 less than C. A lot of people think less than subtraction, and it is. So they'll say 1 minus C. That is incorrect. To understand how this one works, I'm going to take you to a different example. If I said 2 less than 5, a lot of you would know the answer to that question. If you don't, pause it. What is 2 less than 5? It's 3. 2 less than 5 is 3. We know that. But if you write it the way it's written and say 2 minus 5, you get negative 3. But you know that that's not right. When you see this less than, you're basically going to be taking the two parts and flipping them. Okay, so the correct expression here is C minus 1. So the number of children minus 1 is kind of how you read that. Okay, flip it over to the back side. What I talked about, reading the directions can clue you into what you should be expecting. So if I'm looking at this, I'm seeing define variables. Right there is a clue. And write an algebraic equation. Again, a clue. Equation, I should have an equal sign here, somewhere. And variables implies that there's 2 or more variables. More than one, right? So, let's look at the first problem. The number of gallons of water used is 30 times the number of trees. So the two things we don't know are the number of gallons of water and the number of trees. There's my two variables. So I'll say G is my number, which that symbol, the hashtag, can stand for number of gallons of water, and T I'll use for number of trees. Again, notice I didn't just say gallons and trees. I said number of gallons and number of trees. And now we can break this down to write our equation. The number of gallons of water, which we can replace all of that with G. So G is, so G equals 30, we can write 30 as a number, times the number of trees. Well, the number of trees I can say is T, so 30 times T, or just 30T. And there is my equation. Okay. Number 2, the number of goats is 10 less than triple the number of rabbits. Again, the two unknowns are the number of goats and the number of rabbits. We need to define them. G is number of goats. R is number of rabbits. The number of goats, G, is equals 10, oh, there's that less than again. That should remind you to go with these two things and switch them. So I'm going to start here, triple the number of rabbits. So how do I write triple the number of rabbits? 3 times the number of rabbits, or 3 times R, less than, or sorry, yeah, minus 10. Okay. Last one is definitely a challenging one here. My variables aren't very hard to define because they're set up this way. This is what I was talking about. These are changing values. That's one of the definitions of a variable, a changing value. So my first one is, I'll say C, and that's standing for total cost. And change from a 10, I'll just say N for change. And I guess we could say change from $10. Like I said, this one is tricky. So if you look at this, the way you get your change is you take what you pay with. So you paid with a $10 bill. That's what this is saying. You're giving a $10 bill and you're wondering how much change you're going to get back. So if you're paying with a $10 bill, you're going to subtract the cost of the item. I would not expect you to get that on your own right now, but you should understand where that came from. I'll give an example. If I have something that costs $4, the way I get my change is I take whatever I paid minus the $4 and get $6 as my change. So there's my equation. Okay, we're going to spend a lot of time working on this. We're going to use this a lot in word problems. So the better you are with this stuff, the better off you'll be with word problems. But if you have questions, make sure you're asking in class.